Bismillahirrahmanirrahim. Assalamu alaikum. The LU decomposition is a technique which is used to solve system of equations. The LU decomposition has three types: the Doolittle decomposition, the Crout decomposition, and the Cholesky decomposition. In this video, we shall explain all these three types of the LU decomposition. To discuss different types of the LU decomposition for the solution of system of equations, for convenience, we consider this system of three equations. Now, this system in the matrices form can be written like this one. Here, this is a matrix of coefficients denoted by A. This one is X and this is B. Therefore, from here we can get AX is equal to B. And now let us explain the first method, which is called the Doolittle decomposition. According to this method, we can solve a system of equation in three steps. In the first step, we have to decompose a matrix A. In other words, we have to write A is equal to LU, where L will be given by this matrix. This is the lower triangular matrix, but all elements of this lower triangular matrix on the principal diagonal are 1, 1, 1, and U is given by this one. After multiplying L with U and comparing the coefficients or the corresponding elements on both sides, we can get the values L1, L2, L3, and U1 up to U6. So in this way, in step 1, we can find L and U. After getting L and U, we should go to step number 2. And step number 2, we shall solve this equation, Ly is equal to B. Now in step 1, we have already obtained L and B is given by this matrix. Now putting values and solving this equation, we can find the values of y1, y2, and y3. In other words, we can find y. Once we get y, we can go to the last step number 3. In the last step, we will solve ux is equal to y. Now u, we have already obtained it in step 1, and y, we have obtained it in step 2. Putting the values and solving this equation, we can get the required solution x. In other words, we have to find x1, x2, and x3, and that will be the required solution. In the Crout decomposition method, we can express A in a similar way as a product of two matrices, lower triangular matrix and upper triangular matrix, where the lower triangular matrix is given by L and the upper triangular matrix U is given by this one. But we can see that in this method, in the upper triangular matrix, all elements on the principal diagonal are 1, 1, 1. So multiplying L with U and comparing the corresponding elements on both sides, we can get the value of L and U. Then we can go to step number 2 to solve Ly is equal to B and get the value of y. In the last step number 3, we solve ux is equal to y and get the required solution x is equal to x1, x2, and x3. The last method, which is called the Cholesky decomposition or factorization method, we do the same procedure. We write A is equal to LU. But in this case, L is a lower triangular matrix given by this one, and U is the transpose of this lower triangular matrix. So the upper triangular matrix U is equal to L transpose. From this step, we can find the value of L and U, and in a similar procedure, we go to step number 2 to solve the equation Ly is equal to B for Y. Once we get the value of Y, we go to the last step, Ux is equal to Y. Solving this equation, we can get the required solution x is equal to x1, x2, x3. However, we have to remember this note that in the Cholesky factorization method, the square matrix A, which is the matrix of coefficient. So this matrix of coefficients must be a symmetric matrix and positive definite. Symmetric means A transpose must be equal to A. In example 1, we use the Crout's method to solve this system of equations. In a usual way, the matrix of coefficients is given by this one. X is a matrix containing these variables, and B contains all the constants on the right hand sides. According to the Crout's method, the lower triangular matrix is given by L and the upper triangular matrix is given by U. And we can see that according to this method, in the upper triangular matrix, all elements on the principal diagonal are 1, 1, 1. To solve the system, the first step is to express A into the product of L and U. So let us put values. The values of A are 2, 1, 4. 8 minus 3, 2. 4, 11 minus 1. And now let us put the values of L, which is L1, 0, 0, L2, L3, 0, L4, L5, L6. And the values of U, we can write 1, U1, U2, 0, 1, U3, 0, 0, 1. In the next step, we are multiplying L and U. So we have L1, then we have L1, U1, then we have L1, U2. And now we have L2 here, L2, U1 plus L3. And now we have L2, U2 plus L3, U3. In the last step, we have L4, and now we have L4, U1. And now plus L5. And in the next step, we have L4, U2 plus L5, U3 plus L6. Comparing the corresponding elements on both sides, we have L1 equal to 2, and then we have L1 U1, which is equal to 1, but L1 is 2, so we get U1 is equal to 1 over 2. And comparing the third one, we have L1 U2. This is equal to 4. But we can see that L1 is 2. So U2 is 2. Comparing the next element, we have L2. This is equal to 8. And now L2 U1 plus L3. This is equal to minus 3. Let us put values. L2 is 8 and U1 is 1 over 2. So we have 4 plus L3 is equal to minus 3. Simplification gives L3 is equal to minus 7. Comparing the next element, we have L2 U2 plus L3 U3. That is equal to 2. Let us put values. L2, which is 8, U2 is 2. 8 2s are 16. 16, but L3 is minus 7. U3 is equal to 2. And from here, we get the value of U3, which is equal to 2. Now let us compare the next element. So L4 is equal to 4. And now L4 U1 plus L5. This is equal to 11. Let us put values. L4 is 4 and U1 is 1 over 2. So we have 2 plus L5 is equal to 11. And from here we can get the value of L5, which is equal to 9. The last element is L4 U2 plus L5 U3 plus L6. This one is equal to minus 1. Let us put values. L4 is 4 and U2 is 2. 4 2s are 8. L5 is 9 and U3 is 2. So 9 2s are 18. Plus L6 is equal to minus 1. If we simplify, we can get that L6 is equal to minus 27. Hence, we have the values of L. The values of L are 2, 0, 0, 8, minus 7, 0, 4, 9, minus 27. And the values of U, which we can write 1, 1 over 2, 2, 0, 1, 2, 0, 0, 1. In the next step, we shall solve Ly is equal to B. So let us put values in this one. We have 2, 0, 0, 8, minus 7, 0, 4, 9, minus 27. And Y is Y1, Y2, Y3, which is equal to B. So the values of B are 12, 20, 33. Now solving this, we have 2y1 is equal to 12. So from this we get the value of y1, which is equal to 6. Now from the next equation we have 8y1 minus 7y2. This one is equal to 20. And if we put the value of y1 and simplify this, we can get that the value of y2, that one is given by 4. And now from the last equation we have 4y1 plus 9y2 plus, minus 27 minus 27y3, that is equal to 33. Putting values and simplifying this, we can get the value of y3, which is equal to 1. So we have y is equal to 6, 4, 1. And now let us solve the last equation, which is ux is equal to y. Putting values in this equation, we have 1 over 2, 2, 0, 1, 2, 0, 0, 1. And the values of x, we have x, y, and z. And this is equal to y. So y is 6, 4, and 1. Let us solve this system. From here we get x plus 1 over 2y plus 2z is equal to 6. Let us say this is equation number 1. Now we have y plus 2z is equal to 4. And now we have z is equal to 1. So from 3 we have the value of z. Let us put this value in 2. So we have y plus 2 is equal to 4. And from here we get that y is equal to 2. Now let us put values in equation number 3. So we have x plus the value of y is 2. So we have 1 over 2 into 2 is 1. The value of z is 1. So we have 2 here. This is equal to 6. And if we simplify, we get x is equal to 3. Thus we have the required solution x, which is given by 3, 2, 1. In this example, we shall use the Cholesky method to solve this system of equations. In a usual way, we can write a, x, and b, and then according to this method, the lower triangular matrix is given by L, and the upper triangular matrix is the transpose of this L. So the first step is now to write matrix A as a product of L and U. So let us put values. Now A is given by 4, 2, 6. And 2, 82, 39. 6, 39, 26. And now let us write matrix L, which is given by L1, 0, 0, L2, L3, 0, L4, L5, L6. And now let us write matrix U, which is transpose of L. So we can write L1, 0, 0, L2, L3, 0, L4, L5, L6. And now in the next step, we are going to multiply L with U. So we have L1 square, and the next step we have L1, L2. Then we have L1, L4. And now we have again L1, L2. Here we have L2 square plus L3 square. And here L2, L4 plus L3, L5. Now we have L1, L4. And here we have L2, L4 plus L3, L5. In the last entry we have L4 square plus L5 square plus L6 square. And now let us compare the coefficients on both sides to find the values of L1, L2, and so on. So we have L1 square is equal to 4, and from this we get L1 is equal to 2. The next entry is L1, L2 is equal to 2. But we know that L1 is 2, so we get L2 is equal to 1. And from the next entry, we get L1, L4 is equal to 6. But we can see L1 is 2, so we get L4, which is equal to 3. And now in the next step we have L2 square plus L3 square is equal to 82. And now if we put values, we have 1 plus L3 square is equal to 82. And if we further simplify this, we have L3 is equal to 9. And now from the next one we have L2, L4 plus L3, L5. This is equal to 39. So let us write this is 39, and if we simplify this, from this we have the value of L5, which is equal to 4. And now let us get the last value. So from the last entry we have L4 square plus L5 square plus L6 square. This is equal to 26. And if we simplify this, we get the value of L6, which is equal to 1. Therefore, we can write that the lower triangular matrix is 2, 0, 0, 1, 9, 0, 3, 4, 1. And the upper triangular matrix, we know this is transpose of L. So we can write 2, 0, 0. Then we can write 1, 9, 0. And now we can write 3, 4, 1. So now we can go to the next step in which we solve the equation Ly is equal to B. So let us put values in this equation. The value of L is 2, 0, 0, 1, 9, 0, 3, 4, 1. And the value of Y, this is Y1, Y2, y3, which is equal to B, and matrix B is given as 16, 206, 113. And now let us solve this system. So from here we have 2y1 is equal to 16, which gives y1 is equal to 8. From the next one we have y1 plus 9 y2. This is equal to 206. But y1 is 8. So we can write 8 plus 9 y2 is equal to 206. And if we further simplify this, we can get that y2 is equal to 22. From the last equation, now we have 3y1 plus 4y2 plus y3. This is equal to 113. And now if we put values and simplify this equation, we get that y3 is equal to 1. So we have the value of y, which is given by 8, 22, 1. And now let us solve ux is equal to y to get the required solution x. So the value of u, which we have, is 2, 0, 0, 1, 9, 0, 3, 4, 1. And x is x1, x2, x3. This is equal to y, which is 8, 22, and 1. Let us solve this system now. Multiplying these equations, we have 2x1 plus x2 plus 3x3. This is equal to 8. Let us say this is equation number 1. 9x2 plus 4x3. This is equal to 22. Let us say this is equation number 2. From the third one, we have x3 is equal to 1. Let us say this is equation number 3. So now from 3, we have the value of x3. So therefore, putting this value in 2, we have 2 implies 9x2 plus 4 is equal to 22. And if we further simplify this, we get x2 is equal to 2. And now let us get the next value from equation 1. So we have 2x1. The value of x2 is 2. The value of x3 is 1. This is equal to 8. And if we further simplify this, we have x1 is equal to 3 by 2. Hence, the required solution x. This is given by 3 by 2, 2, 1. That's all.